Hello there. Today's topic is From Infrastructure as Code to Environment as Code. Challenges scaling ISC and how to resolve them. This talk is based on my and my team's experience working with and helping various companies adopt infrastructure as code and the challenges we have seen scaling infrastructure as code over the years. I will also introduce environment as code, which has helped us resolve those challenges. Some of what you will hear today around environment as code is new, and I would love to hear what you think about it, answer any questions, and discuss it further. My name is Adarsh Shah. I am the founder and CEO at CompuZest. We all know what infrastructure as code is. It helps us automate provisioning of infrastructure resources. It is one of the key DevOps practices that enables teams to deliver infrastructure rapidly and reliably. Here's a typical evolution of your ISC. You probably start with a very simple setup, a monolith ISC with a single ISC run. If you are using Terraform, then that means a single state file. As you can see in the diagram on the left, it has networking, platform EC2, and S3 bucket all in a single monolith ISC run. As you scale, you start breaking the ISC into separate, smaller ISCs. As you can see in the diagram on the right, there is a separate networking ISC, and then platform EC2, platform K8s, and Postgres that depend on networking, and then K8s add-on that depends on platform K8s. This talk is focused on teams who have already broken down their infrastructure as code into smaller runs or looking to do that. If you have a very simple setup and can just execute it as a single run, you won't have most of the challenges we talk about today. For the execution of your ISC, it probably starts with running it on the engineer's machine. But as you mature, you have more members of the team that want to run the ISC and want a more reliable and stable execution environment. You create a pipeline or use GitOps to execute the infrastructure as code from a shared environment. This talk is focused on teams who already use pipelines or GitOps or looking to do so. Application teams need an entire environment, something like you see in the diagram, to deploy and operate their applications. Just getting networking, platform K8s, or RDS database on its own is not going to allow them to run their applications. They need an entire environment, whatever that might mean for the team that has the various infrastructure resources and dependencies between them. In this example environment, networking needs to be provisioned first, and then platform EC2, platform K8s, and then the K8s add-ons. If you want to get an environment like this using infrastructure as code, here are your options. Create a monolith ISC. But we all know this is bad. It creates a tight coupling and is not recommended unless, of course, you have a very simple use case. The state files become large and it becomes painful to maintain them with a monolith ISC. Option 2 involves hand-rolling pipelines, using tools like Jenkins, CircleCI, etc. to run the ISC and manage complex dependencies in the pipeline code. While your ISC is declarative and idempotent, these pipelines are not. You have to write a lot of custom code to provision an entire environment. Teardown must be supported, and any failures, errors that impact the environment must be accounted for as well. If there are failures or errors while execution, they usually get managed manually by engineers. As you can tell, these options are inefficient, costly, and typically requires a dedicated team. Here are some other challenges scaling ISC. If you want to follow principles like immutability for your environments or make it easier to share best practices implementation of environments across various teams, having a mechanism to easily replicate environments is critical. Since the pipelines I mentioned in the previous slide are not ideal for managing entire environments, it becomes painful to replicate them. Teams spend a lot of time writing custom code to replicate environments. Visualizing and understanding environments are challenging too. Teams also struggle to do that. Trying to find that information by going directly to the cloud provider's dashboard is even more confusing. If they want to troubleshoot an issue, share knowledge between teams, or make any changes to existing environments, they need to go through a painful and time-consuming process. A lot of teams create diagrams for their environments with various infrastructure resources and how they are connected using tools like Visio or Draw.io, but these diagrams get out of date soon with real environments. Instead of helping, they actually provide incorrect information and can cause confusion. Over a period of time, due to human error or indirect changes, provisioned infrastructure drifts from the desired state in code. While with existing solutions, like using a pipeline to execute ISC, drift can be directed. Since ISC is declarative, but only when that pipeline executes the ISC next time, and it will only find drifts within that particular ISC. Teams should know about the drift right away, and not just for individual infrastructure resources or a few of them, but for the entire environment and various component dependencies so they can remediate any issues as soon as possible. Now that we understand the challenges scaling infrastructure as code, let's understand what environment as code is and how it helps resolve those challenges. We can start by looking at a high-level diagram of environment as code. So environment as code is an abstraction over infrastructure as code. As you can see in this diagram, environment as code is declarative and executes and manages various infrastructure as code components. Various ISC components are responsible for provisioning infrastructure resources. EAC is responsible for executing infrastructure as code in the right order. If we use the Lego analogy, infrastructure as code automates various Lego pieces that are your individual infrastructure resources or a few of them together, while environment as code automates how these Lego pieces are connected to make up a Lego toy, your entire environment. Here's the definition. I know it's long, but I think it's important to go through it. Environment as code, EAC, is an abstraction over infrastructure as code that provides a declarative way of defining an entire environment. It has a control plane that manages the state of the environment, including relationships between various resources, detects drift, as well as enables reconciliation. It also supports best practices like loose coupling, idempotency, immutability, etc. for the entire environment. EAC allows teams to deliver entire environments rapidly and reliably at scale. Now let's dig deeper into provisioning workflow using environment as code. So if we start at the top, we define our environment as code, which is declarative. We push it to source control. Control plane that's associated with environment as code picks up that change. It manages the state of the entire environment, including any dependencies between various components, their statuses, etc. And then it starts reconciling various infrastructure components. These are infrastructure as code pieces that have their own state. So if you're using Terraform, like you have in this instance, networking is actually Terraform code, and Terraform manages the state of that networking component. And then once networking is done, it provisions platform KDAS and Postgres. So the control plane that's associated with environment as code manages in what order these components run. And then after that, the KDAS add-ons runs. So as you can see, the control plane is what that manages all of these various pieces, but infrastructure as code, Terraform in this case, is actually responsible for provisioning resources in your cloud provider. And then for the teardown, it reverses the logic and starts from the leaf node and then goes up the chain. So now that we looked at what environment as code is, let's look at the various attributes of environment as code. Environment as code manages an entire environment. So it should support defining that entire environment with various infrastructure components in an easy to understand format. It also supports specifying various relationships between these components. This diagram shows an example environment as code using the YAML custom format. We use this for our product, Z Lifecycle, but it doesn't have to be a YAML format. Anything that you can use to specify the entire environment, any format can be used. As you can see on line 54, it allows you to specify the type of infrastructure as code, which is Terraform in this case, and also that this component depends on the networking component. Environment as code promotes loosely coupled IAC components, like you see in the diagram. It brings these loosely coupled IAC components together to give an entire environment. Like infrastructure as code tools have state files to capture the state of each IAC run, environment as code also has a state file that captures the state of the entire environment, including the various components and their relationships. As you can see in the diagram, it has operation and status that tells you about the last run of what type of operation it was and what's the current state. It also tracks component operation and status from the last run. Idempotency and immutability are key principles for infrastructure as code. How do you apply these to an entire environment? Let's first understand what they mean in case you're not aware of these principles. Idempotency means no matter how many times you run your IAC or your code and what your starting state is, you will end up with the same end state. This simplifies the provisioning of infrastructure and reduces the chances of inconsistent results. So let's look at when you start at the top. Let's say you want 3 VMs. Your code provisions 3 VMs. In non-idempotent case, if you reapply the change, you get 3 more VMs. So if you are expecting 3 VMs, you actually end up getting 6 instead. On the idempotent side, though, if you reapply your change, it knows that you already have the 3 VMs, so it won't provision any new VMs if you reapply the changes. So you end up getting the 3 expected VMs. With EAC, you can achieve idempotency for the entire environment, as it tracks state for the entire environment and knows what the last operation was and its state. Pipelines don't do that for you. Configuration drift is a huge problem with infrastructure. It occurs when over a period that there are changes made to infrastructure that are not recorded, and your various environments drift from each other in ways that are not easily reproducible. This usually happens if you have a mutable infrastructure. that lives for a long time. These issues can be resolved by using immutable infrastructure. So as you can see on the left, if you want, you have version 1 of your code or your infrastructure as code deployed. You make some changes to your code, and in case of mutable infrastructure, you apply the new version to the same infrastructure. So you have long-lived infrastructure. In case of immutable infrastructure, when you make a change, you actually provision a brand new set of infrastructure with the new version, redirect traffic to that new version, and then get rid of the old infrastructure. Immutable infrastructure means instead of changing an existing infrastructure, you replace it with new. By provisioning new infrastructure every time, you're making sure it is reproducible and doesn't allow for configuration drift over time. Why not apply this principle to the entire environment? You can do that using environment as code. You can replace entire environments by bringing brand new environments up instead of changing existing ones to achieve immutability. As mentioned earlier, teams usually create diagrams manually and then keep it updated as they change code. You all know how that goes. The diagrams get out of date over a period of time and provide misinformation and are more harmful than useful. Since environment as code is a simple, easy to understand format, you can use it to create a visual that helps teams understand their as well as other teams' environments within their organization. This screenshot is from our product Z Lifecycle that is created using the environment as code concept. Environment as code has a control plane that contains a reconciler that observes whether the desired state and the current state have drifted and then reconciles them. You might be thinking this looks like Kubernetes controllers, and yes, it is based on the same concept. In fact, you can use Kubernetes controllers to achieve it. In this case, though, it probably makes sense to have an approval step that shows the plan before bringing the actual status back to desired state. And this might involve destroying or recreating infrastructure. Comparing and promoting changes across various environments becomes a lot easier with environment as code. Since environment as code is an easy to understand format and push to source control, you can compare the code for various environments and promote changes. You can also use GitOps for the entire environment using environment as code. So let's look at how the GitOps flow would look like with EAC. We start on the left, you define your environment code. You can add push to a branch. You validate if everything is valid and create a pull request. Someone from your team looks at the PR, approves the PR, and then it eventually gets merged to main. There is a control plane that's associated with environment as code that observes the repository, picks up a change, and then starts the reconciliation process. Thanks everyone for attending my talk. Please feel free to reach out if you have any questions about environment as code, infrastructure as code, and also we have a product that uses the same environment as code concept. So check it out. It's called Z Lifecycle. And as I mentioned at the start, I would love to get your feedback on environment as code and discuss it further. Thank you again.